This is Professor White. Today we will study quadratic equations and primarily the completing the square method. Okay, when we talk about quadratic equations, you can have them in a bunch of different forms, and the most common forms are in standard form when it looks like this: ax squared dx plus c. And you remember this is called the leading coefficient. This one is coefficient of x, and this one is the constant term. This one is the degree of your polynomial. And here the degree of x is 1, and the degree of x here is 0. The whole thing is called the quadratic equation, okay? Or this is a quadratic expression, and if you have an equal something, that's going to give you an equation. All right, so it's actually pretty much a polynomial of second degree. When you put the quadratic equations in vertex form, you're going to have something like this: f of x equals something, and then that's going to be in the vertex form a number, x minus h squared plus k, where h, k are the coordinates of your vertex. What is a vertex? We'll talk about that. And the factored form is going to be pretty much a number, for example, and you can have it in a factored form. You can have some other coefficients here, but what's important is you're going to have two factors that involve x's to make it a second degree. All right, so I can have it in a bunch of different ways, and then you can have it like equal to something, and we're going to try to solve these quadratic equations. All right, usually it is set to 0. If it's not set to 0, you just have to go and do something about it. Now let's say we have a quadratic equation that is like this: x squared equals 4. We can use factoring for it. To do factoring, you know how to do factoring. You need to have everything on one side. So subtract 4. Then you have x squared minus 4 equals 0. Then factor the left-hand side. This is a plus ba minus b, x plus 2, x minus 2. Then what was the procedure? You set each factor to 0. X plus 2 is 0. That means x is negative 2. X minus 2 is 0. That means x equals 2. So we use factoring to solve a quadratic equation. Well, let's use the square root method. Same example. With the square root method, what you need to do is you need to take square root of both sides, and be careful. When you take the square root of something that has an x in it, you get absolute value of x. So just remember that. This one is 2. When you remove the absolute values, you're going to get plus minus x. And then you move the plus minus on the other side, which means x equals 2, x equals negative 2. And if you look at the previous page, it is the same answer. All right, let's use square root method for this one. I'm going to do the same steps. This one is going to be absolute value of x minus 1. When you remove the absolute value, you're going to get plus minus. Move the plus minus on the other side. Then you're going to end up with, move the 1 on the other side. Now look at what that means. X equals 1 plus 2, which is 3, or x equals 1 minus 2, which is negative 1. Do you see the steps? All right, the steps are exactly the same. All right, let's do this one. What happens when I have taken square root of both sides? Now you have to be careful, because you're taking square root of a negative number. That will give you an imaginary number. Again, this will give you x minus 1. What will this give you? This will give you 2i. All right, let's proceed the way we did before. Plus minus. Move the plus minus on the other side. Then move the 1 on the other side. Now write down what that is. X equals 1 plus 2i. X equals 1 minus 2i. What did you end up having? You ended up having a complex pair. All right. Well, what happens when you don't have a perfect square on the right? Okay, well, it's good. Let's see what we have. X minus 1. What is this? This is 3 times 4. Square root of that is going to give you 2 rad 3. Leave it that way. That's okay. Plus minus. Then you move the plus minus on the other side. Then you move the 1 on the other side. And write down what you have. Plus and minus. You have 2 of them. But what happened with this one, you got 2 real answers, but they are irrational because you have square root of 3 in there. Well, let's do one like with the irrational real part and a negative. Put it all together. Take square root of both sides. This will give me x minus 1. What is this? This is 2 times 9. Then take it out. You're going to end up with 3 rad 2. And because of negative, I. All right. Remove the absolute value. Now you have this. Move the plus minus on the other side. Then move 1 to the other side. What did you end up? You ended up with a complex pair, and the coefficient of I is irrational. 1 plus 3 rad 2i, 1 minus 3 rad 2i. Very good. Now remember, what we were doing so far, we had the perfect squares on the left side. Now, you may not have it in that form. So what you need to do is you need to write it as a perfect square. I know this is a perfect square of x plus 1. So what you need to do is just write the left-hand side as a perfect square somehow. Then proceed. Then you're going to end up with x plus 1 on the left, rad 5 on the right. Remove the absolute value. You are going to get plus minus. Move the plus minus on the other side. Move 1 to the other side. Now what did you end up having? 2 parts. X equals negative 1 plus rad 5. X equals negative 1 minus rad 5. 2 irrational real answers. Okay. Here's a perfect square. Let's do it fast. X minus 1. X minus 1. X minus 1. X equals negative 1. Negative 1 plus 2. Negative 1 minus 2. Plus 1. Negative 3. All right, so this example actually looks very, very easy. Well, let's remember what perfect squares look like, because I keep on repeating that. Perfect squares look like this. When you FOIL it, let me FOIL it slowly. X squared plus 2x plus 2x plus 4. X squared plus 4x plus 4. This one is the square of this. And this one is the square of that. Now, what is the middle one? Middle one is when you go and multiply these two, that I circled, 2x, and you double it. Okay, well, let's see if that works. So let me fast FOIL it this way and kind of double check. First one squared, last one squared. Since it's negative, negative. Multiply 2 and x, 2x, double it, 4x. Is that the case? I think so. Watch. X squared minus 2x minus 2x plus 4. Yes, it looks like this term is double first and last. I'm going to remember that. Now, let's go one more step. If somebody says, how can you make this adding something as a perfect square? This is a perfect square of what? I know that it has an x in it, but what is that guy? So remember how it went. This term is going to be twice first and last. So going backwards, I can take 6 divided by 2. That's 3. Okay, that's the last term, and that's squared. That's 9. So take this, divide by 2, and square it. That's what the missing term is. The missing term is 9. And what will go here? This thing that I divided. X plus 3 squared is x squared plus 6x plus 9. Let's do the same exercise with that one. Divide this by 2, negative 4. Square it, positive 16. And what is that perfect square of? That's a perfect square of this guy, minus 4. All right. Now, I know how to make, something in perfect square by just putting that missing thing. But what happens when you already have something in there? We're going to do that. But let's do some more complex things. How can I make this a perfect square? What was the procedure? You take this, divide by 2. Keep it as a fraction, as 5/2. Now square it. Square it means 5/2 times 5/2. What does that give me? 5 times 5, 25. 2 times 2, 4. That's the missing piece. And that's the missing piece of what? X plus, what is this number? 5/2. All right, so that wasn't too bad. It's just a fraction. Now how do I do this one? I'm supposed to take this and divide by 2. What the heck is that? Negative 2/5 divided by 2, which is negative 2/5 times 1/2. Look what happens. These two go, and you end up with negative 1/5. So when I divide by 2, I get negative 1/5. Square that. What do you get? 1/5 times 1/5, 1 over 25. And that is the square of what? X, because of that minus is minus. What is this number? 1/5 square. Okay, I think I did enough, and I did pretty, so you can watch this part again if you want. Now we're going to put this concept together with the whole method of completing the square. This is how you do it. The goal is to solve a quadratic equation like this. You have 0 on one side, everything else on the left. What you do, move the constant term to the other side. So you get that. Divide everything by the leading coefficient. And then on this, you're going to do complete the square. In other words, you're going to add this missing piece here and the same piece on the other side. Then proceed as taking square root of both sides. All right, so let's go do an example. What are the steps? Move the 5 to the right. Step 1. Here's what you have, x squared plus 6x equals negative 5. So if you have something in here, then what you need to do is you need to divide both sides by that. But this is 1, so it's not going to make any difference to do this. So you still have the same thing. X squared plus 6x equals negative 5. Remember, now I'm looking for the missing piece. How do I get the missing piece? take this, divide by 2, that's 3, square it, that's 9. Here's 9. But you cannot just do 9 on the left, you have to do 9 on the right. Well, let's move on. What do you have? X squared plus 6x plus 9 equals 9 minus 4, which is 4. Now write this as a perfect square. Yes, this is the perfect square of this. Guess what? Now we have a situation where I can just go ahead and solve this. Okay, let me get some papers. All right. What was the steps? You're going to go take square root of both sides. So you're going to get absolute value of x plus 3. You get 2. Remove the absolute value. That means x plus 3 is plus minus. Then move the plus minus on the other side. Then move the 3 on the other side. Okay, what does that give me? It's going to give me 2 parts. X equals negative 3 plus 2, which is negative 1. And x equals negative 3, negative 2, which is negative 5. Now that's interesting. I actually used the complete in the square method. Alright, remember how that went. Move the constant over, divide by the leading coefficient, add the missing piece, take square root of both sides, don't forget absolute values, and get done. Alright. Well, let's do something a little harder. How does that work? Same kind of problem. Same steps. Get rid of the constant term. Now I'm going to put the missing piece. 6 divided by 2 is 3. Square it, that's 9. This will have 9. This will have 9. Then you rewrite x squared plus 6x plus 9 equals negative 1. Write the left-hand side as a perfect square. This is the perfect square of this. Now what do? Take square roots. On the left, you're going to get absolute value. On the right, you're going to get an imaginary number. Remove the absolute value. Then move the plus minus on the other side. Move 3 on the other side. What did you end up having? You ended up having a complex pair. Negative 3 plus I, negative 3 minus I. Why? Because I ended up with a negative number on the right. Alright, let's do this problem. Again, the leading coefficient of 1. Subtract. What is important about this one? You're going to end up with a fraction. I wanted to show you how that works. Now, let's divide 7 by 2. Ooh, 7 over 2. Now square it. You have 49 over 4. Okay? You put that here. Alright. Now what do you have? On the left, x plus 7 over 2 squared. On the right, negative 6 plus 49 over 4. That means 4 times 6, 24. Negative 24 plus 49 over 4. What is negative 24 plus 49? That looks like 25. Okay, this is what I have. X plus 7 halves, 25 over 4. Now I have a perfect square on the left, square root. I'll get an absolute value. and I'll get 5 over 2. Remove the absolute value. The steps are always the same. Move the plus minus on the right. Now move the 7/2 to the right. You have two parts. -7 plus 5 over 2. -7, -5 over 2. This one will give me -2 over 2, which is -1. This one is going to give me -12 over 2, which is -6. Very good. Now I'm going to do an ultimate problem, and now we're going to summarize what we just did. So let's arrange things. All right. Okay. A leading coefficient that's pretty ugly. Okay. Move the constant term. 2/3 x squared plus 4/3 x equals -1. We're going to do them slowly. 4/3 divided by 2. Oh, before you do that, you have to divide both sides by 2/3. All right? So let's go. This will give you x squared plus 4/3 divided by 2/3 is 2. Remember, I'm just doing it division. So that one is 4/3 times 3/2, right? So you'll end up with 2. All right. So x squared plus 2x. And what do you have on the right-hand side? You're going to end up with 1 over 2/3, which is 3/2. Okay? But don't forget the negative. All right, very good. Now what am I missing? Take this, divide by 2, that's 1, square it, that's 1. So you're missing a 1, you're missing a 1. So what do you have on the left? X squared plus 2x plus 1. On the right, -3/2 plus 1, which is 2/2, which is -1/2. Does it make sense? It's hard to grab these guys. All right, this is where I am. I need to go and write this as a perfect square. X plus 1 squared is going to go -1/2. Take square root of both sides. You're going to end up with x plus 1 in absolute value. And what is that? Because of negative, you have an I, and this is 1 over rad 2. Which is the same as rad 2 over 2. Rationalize the denominator. Okay, now remove the absolute value. You're going to end up with plus minus. You have rad 2 over 2i. Move the plus minus on the other side. You're going to end up x plus 1 equals plus minus rad 2 over 2i. Move the 1 to the other side. X equals -1 plus minus rad 2 over 2i. You can actually put it in the same denominator if you want. -2 plus minus rad 2 over 2i. Okay, what's that mean? X equals -2 plus rad 2i over 2. or x equals negative 2 negative rad 2 I over 2. All right, so this is the end of this section.